All right, one of the things I've noticed that we're not doing consistently is labeling our notes. So go ahead and label the top of your notes, solving quadratics using square roots. And the other thing you want to get in the habit of is keeping your notes separate from your work. One of the major goals of being able to factor is to solve quadratics and other polynomial equations. So what we're going to do here now is sort of step aside from the factoring for a second and learn another method of how to solve a quadratic. Before we do that, we've got to talk about a few basic properties of square roots. So first we're going to start with the square root of a times b. The square root of a times b can be rewritten or re-expressed as the square root of a times the square root of b. So take, for instance, my favorite, the square root of 27. That could be rewritten as factors 9 times 3. So that could be rewritten as the square root of 9 times the square root of 3. Well, the square root of 9 is 3 times 3. Or we just say 3 radical 3. So the square root of 27 is equal to 3 radical 3. That's how we reduce square roots. Let's try a couple more. Okay, first we have the square root of 28. The square root of 28 can be re-expressed as 4 times 7, which is the square root of 4 times the square root of 7, which is 2 radical 7. Next, we have the square root of 32, which is the square root of 16 times 2, which is equal to 4 radical 2. Now, probably a lot of you thought of the square root of 32 as 4 times 8, which is the square root of 4 times 4 times 2, which is the square root of 4 is 2. The square root of the next 4 here is also 2 radical 2, which is 4 radical 2. So either way, 4 radical 2 is our final answer. How about the square root of 21? That's the square root of 7 times 3. Neither one of those are perfect square roots, so the square root of 21 is already reduced in its simplest form. That's it. What about when I have the square root of 6 times the square root of 21? Well, that's the square root of, or I should say that's like a times b. So what I want to do is I just want to break these down. So let's see here. The square root of 6 times 21, well, let's just put them under one big radical for a second. 6, though, as I bring it over, 6 is 3 times 2. And 21 is 3 times 7. Well, that's the same as the square root of 9 times 2 times 7. Just take a minute and digest that, right? 3 times 3 is 9, which is the same as 3 times radical 2 times 7. Neither one of those can be broken down, so that's 3 radical 14. So what's radical 6 times 21? 3 radical 14. Let's try that again. How about the square root of 5 times the square root of, say, 30? Well, that's the square root of 5 times the square root of 30, but I'm going to write 30 as its factors. 5 times 6. Okay. 5 times 5 is radical 25 times 6, which is equal to 5 radical 6. 6 can't be broken down, so radical 5 times 30 is 5 radical 6. You got to be willing to push and pull things apart in order to make things smoother. Well, if there's properties for multiplication, you got to know that there's properties for division. So what about the square root of a times, or a divided by b? Well, that is just like the multiplication piece. You can pull them apart into two separate radicals, where that's the square root of a divided by the square root of b. So take, for instance, the square root of 2/25. That can be rewritten or re-expressed as the square root of 2 over the square root of 25, which is radical 2 over 5. I just want to make sure that we understand that that's the same as 1/5 times radical 2. Now, I prefer this answer, but you should recognize them both as the same thing. And again, how do I know? Well, because that's 1/5 times radical 2 over 1, and you see how important it is to be able to multiply fractions now. 1 times radical 2 is radical 2. 5 times 1 is 5. So these guys are the same thing. Okay. Let's try a couple of practice examples. So the square root of 24, or square root of 4 over 25 is the square root of 4 over the square root of 25, which is 2 over 5. Done. Square root of 3 over 81 is radical 3 over radical 81. So that's radical 3 over 9. I know you're tempted to reduce that, but you can't pull the 3 out of the radical. It's protected. It's like being inside a parenthesis. So that's it. Right? Or 1/9 radical 3. But again, I prefer that one myself. But you should recognize both answers as being the same item. So how can we take this newfound knowledge of learning how to reduce radicals into helping us solve quadratic equations? Well, we take this and you're sort of pre-programmed into subtracting 41 from both sides, assuming that the instructions are solve. And you get 3x squared minus 36 equals 0. Okay, well, what would we do? We say, well, Mr. Brecklin says always look for a common factor to pull out, so let's factor out a 3. We get x squared minus 12 is equal to 0. And now we're a little jammed up here because this little ditty right here, well, that's not the difference of perfect squares. I say, well, what do you do? I suppose at this moment you could say, well, 3 equals 0, x squared minus 12 equals 0, and go from there. I'm going to toss that out because that's not true. X squared is equal to 12, square root of x, square root of x squared rather, square root of 12, square root of x is equal to x, and the square root of 12 is going to be the square root of 4 times 3, which is equal to plus or minus 2 radical 3. When we're just reducing radicals, we don't worry about the fact that there's actually two versions of the answer. We only focus on the positive root. But when we're talking about solving square roots, remember that this is a parabola and that it crosses the x-axis, probably in two places. 2 times the square root of 3 on the positive side, and negative 2 times the radical 3 on the negative side. And just so we don't think of that number as some arbitrary number, the square root of 3 is approximately 1.73. So 2 times that number is about 3.46. So this is positive 3.6, and that's negative 3.46. And this is what happens when we have ugly answers. Now, to be honest with you, I wouldn't actually approach it that way. At the very beginning, as I set this thing equal to 0, I would notice that this really isn't going to work out, and I probably would have just followed the instructions, and it would have said solve using square roots. So let's try this exact problem again. I know what you're thinking, Mr. Brecklin, you just wasted my time. Well, not really. Let's just try this again slowly. 3x squared equals 36. Now, if this were just 3x for a second, and if you just forgot about the squared term there, I think you would have taken this divided by 3 on both sides, if you were imagining that 2 was non-existent. So what are we going to do? The same thing. I'm going to isolate that x squared term. So I'm going to get x squared is equal to 12. Now that I have x squared equal to 12, I want to solve for x, not x squared. So I'm going to undo the squared term by taking the square root on both sides. The square root of x squared is x, and the square root of 12 is, guess what still? It is 4 times 3, which is equal to the positive and negative version of 2 radical 3. Why is it both values? Same answer that we had before, by the way. Just to reiterate why it's both values, positive 2 radical 3 times positive 2 radical 3. Well, let's see now. This is the same as saying a times b times c times d. So what I'm going to do is multiply a times c. 2 times 2 is 4. b times d, that's radical 3 times radical 3. And if I could pull radicals apart using multiplication, can I push them together? So that's 4 times radical 3 times radical 3, which is 4 radical 9, which is 4 times 3, which is 12. So positive 2 radical 3 squared equals 12. And if these were both negative, negative 2 times negative 2 would be positive, and that's why positive 2 radical 3 and negative 2 radical 3 both equal that radical 12, if that makes any sense at all. Remember, or I'm sorry, not radical 12, but 12. Remember, we started off originally with 12 and originally with x squared. So when we square x, we end up with 12. All right, so maybe that wasn't perfect. Let's try that again. Okay, let's try again, and I promise not to make a debacle out of explaining the answer. Simply just going to solve using square roots. So instead of setting the quadratic equal to 0, that's how I would attempt to solve it using factoring. I'm going to attempt to solve this by isolating the squared term. So I'm going to get everything away from the squared term. The squared term is z squared. So I add 7 to both sides, and I end up with z squared is equal to 36. Now I want to undo the square because it's isolated. I undo it by taking the square root. Z is equal to plus or minus 6. I think this one's easier to see why it's both answers, because positive 6 times positive 6 is 36, and negative 6 times negative 6 is 36. So it's both answers. A couple more. So now we have something slightly different. What we have here is x minus 2 all squared. So this whole piece here is this squared term. That's the one I want to isolate. So I'm going to isolate that by dividing both sides by 4, which is going to leave me with x minus 2 all squared equals 10. Well, what am I going to do now? I've isolated the square term, so how do I undo the square? By taking the square root of the whole thing. When I take the square root of x minus 2 all squared, it doesn't matter. Just treat this as one item. That's just going to be x minus 2. The squared term falls out. Is equal to plus or minus the square root of 10. And since the square root of 10 isn't simplifiable any more than I see it, I'm going to leave that as is. I'm going to add 2 to both sides. And this is the tricky piece. Since I'm adding 2 to that answer, that's 2 plus the square root of 10 and 2 minus the square root of 10. Or x is equal to 2 plus or minus radical 10. And those are two spots where this crosses over the, or where the parabola crosses over the x-axis. And exactly what are those two values? Well, the square root of 10 is approximately 3.16. So that's 2 plus or minus 3.16. So that's 5.16 on the positive and negative 1.16. That's the actual sort of value of what 2 plus or minus radical 10 is. But we'll just leave it as 2 plus or minus radical 10. Onward and upward. Here we have a couple of steps to isolate the squared term. First thing I see here is that minus 6 on the end. So what am I going to do? Again, just think about this as if it were 2x minus 6 equals 8. What would you have done? You would have added 6, 2x equals 14, and then you would have divided by 2, and what do you got? X equals 7. The quadratic is no different. I'm going to add the 6 first, because these guys are attached by multiplication, so you'll end up with 2x plus 2, that's kind of a haphazard x, equals 14, divide by 2, 2 cancels out, you're going to have x plus 2, all squared, equals 7. Undo that radical, or that square, by taking the square root of both sides. X plus 2 equals, now let's remember that the square root of 7 has two possible answers, a positive version and a negative version, which is 7. Now I'm going to subtract 2 at the end, and I'm going to get x is equal to negative 2 plus or minus radical 7. Now, this is kind of fast in the video, and if you need more time, watch it again. Sometimes